Hello, class. I'm Parker, this is Jacob, and this is George. And today we are presenting our poster for Math 108, Elementary Math Mod Perspective. Our poster talks about how to work with fractions with different grade levels effectively. The goal of our poster is to aid teachers as well as students in understanding how to work with fractions and how fractions work. Our poster is based off an article, Hopping into Fractions, that was written by Kelly Hagan and Chen Yaolin.
This article describes an activity that helps students see that fractions can be represented as equal parts of a whole. It uses a bowl of carrots to show how one task can be adapted from kindergarten through grade 12. Every grade can approach the same problem with different and more complex methods. You can act it out, you can draw diagrams, you can fold paper, or even use algebra. As fractions get more challenging, students can gain a deeper understanding of what parts of a whole and parts of what is left really mean, and how fractions can work in many different ways. This exercise offers teachers new flexible ways to help develop and strengthen their students' understanding of fractions and address the common misconceptions among them. The article uses carrot stick activities from kindergarten to grade 12 to help students understand what fractions really mean. Many students learn how to do fraction problems by following steps, but they do not always understand how fractions work in real situations. Traditional teaching often focuses on memorizing rules instead of helping students see how fractions represent parts of a whole. To make learning more meaningful, the article introduces a set of activities where family members eat pieces of a carrot sticks. This helps students picture how the whole gets smaller as parts are taken away. These activities let students explore fractions in different ways, such as acting out the situations, drawing graphs or pictures, folding paper into equal parts, and later using numbers or algebra to explain their thinking. By moving from simple hands-on tasks to more advanced mathematical ideas, students build a stronger and clearer understanding of fractions. The goal is for them to connect what they learn in class to real-life examples so they can understand fractions deeply and not just remember the steps.
The lesson plan will vary depending on the grade level of the students being taught. The lesson will include some variation of a word problem involving J or their family and a bowl of carrots. The teacher will go over the word problem and work with the students to create a visual representation of the word problem. For preschool students, you could draw out the bowl with the carrots inside and show the carrots being moved out of the bowl and point out how half of the bowl is being removed. For 3rd through 5th graders, you could draw a box and split it into pieces to represent the fractions from the problem and how they relate to each other. For 6th through 8th graders, you could use a piece of paper and fold it into the fractions from the word problem and mark who ate what and how much they ate. The lesson plan covers 2 Common Core standards. The first standard is Common Core Standard Math Content 3.nfa.1. Understand a fraction 1 over b as the quantity formed by one part when a whole is partitioned into b equal parts. Understand a fraction a over b as the quantity formed by a parts of the size of 1 over b. The second Common Core Standard this lesson meets is Common Core Standard Math Content .5.nf.b.4.a. Interpret the product a over b times q as parts of a partition of q into b equal parts, equivalently as the result of a sequence of operations a times q divided by b.
Challenges for students. One challenge is understanding that each fraction represents a different part of the whole because a bowl of carrots changes after each person takes his or her share. Many students will attempt to add fractions directly when they don't realize that the concepts are used slightly different from past math experience, when the whole keeps on shrinking. Another challenge emerges from tracking the sequences of events. In this scenario, students often get confused about how much remains after each step or continue to apply each fraction to the original bowl, instead of the amounts updated for each. Older students may pass over visual models, which makes it harder for them to reason conceptually about fractions and remaining quantities. Younger students may struggle to conceptualize equal sharing without acting out the scenario. Overall, the task requires context, multiple steps, multiplicative thinking, and changing whole skills to solve. The work problem is dependent on the grade level of the students. For pre-K 2 students, fractions are not used, so this can be an introduction to fractions. The problem you can use is if Jay's parent give Jay 10 carrots in a bowl and Jay eats 5 carrots, what fraction of carrots did Jay eat? How do you know? And for 3rd and 5th graders, you can use a problem like Jay and her family decide to split a bowl of carrots. Jay eats 1/2 of the bowl of carrots, while her parents eat 2/3 of the remaining carrots. What fraction of bowl is left? Draw a diagram to show. And for 6th through 8th graders, if Jay brings a bowl of carrots in and eats 1/10 of the carrots, then Kai eats 1/3 of the remaining carrots. Fold a sheet of paper to represent how much carrots are left. If Jay's mom also eats 2/5 of the original bowl, how much of the bowl is left?
The artifact we decided to use is a piece of paper folded up to represent the 6th to 8th grade problem. The paper is folded into tenths, and each letter represents the part that Jay or Kai took. This is one of the ways the article demonstrates how to visualize fractions. The article uses this method slightly different to show how to multiply the remainder of a previous fraction. We chose to fold paper for this example, but there are many other ways you can approach this problem. You can act it out, you can draw diagrams, or even use algebra to solve this problem, depending on the grade level. In class, we learned a couple other ways to approach this problem. First, using blocks which represented equal parts of a whole. Another way we learned to solve this problem was with shapes. These shapes can be broken down into equal parts of 1 whole, 1/2, 1/3, or 1/6. These are just some of the many ways we can approach fraction problems across different grade levels.
This multi-tiered fraction exercise demonstrates how a scenario can aid students in grasping fractions as portions of a whole, when that whole varies. By incorporating visuals, materials, and varying difficulty levels, students start to recognize fractions not merely as figures to calculate, but as segments that vary based on changes in the problem. Progressing from division to looking at all parts across multiple stages helps resolve frequent misconceptions and creates long-term comprehension. In the end, this approach builds flexible thinking and gives students a stronger base for harder fraction work and ratio work.
Beyond enhancing comprehension, this form of scenario-based fraction practice also promotes clearer communication of students' reasoning. While they articulate why the magnitude of each fraction varies at points, they start employing more exact mathematical terminology and support their process and evidence from the model. These discussions assist students in linking abilities to conceptual understanding. An additional advantage is that learners develop the ability to foresee patterns throughout the problem stages, then respond to each phase separately. They begin to forecast how upcoming fractions will act, consider prior altercations in the whole. This proactive approach enhances problem-solving skills and aids students in applying their understanding to context. Finally, this approach fosters a classroom culture where mistakes are viewed as part of the learning process. Because the tasks involve gradually, students can compare their early reasoning with their later conclusions and see how their understanding shifts. This reflection builds confidence and develops persistence, 2 traits essential for success with more abstract fractions and ratio concepts.